So Algebra Lesson 67 is on special systems of linear equations. We've been working with how to solve a system of linear equations. A system means that I have two or more equations. We've been working with two, and the ways that we've gone about solving them is number one, graphing, number two, substitution, number three, elimination. So today we're going to be working with special systems. So this first one is inconsistent equations, where there is no common solution. So it makes the solution false if there is a solution. And then we'll work with the next two, consistent and independent. So this first example is one of an inconsistent equation. So you have negative 3x plus y equals 4 and y equals 3x. Well, I'm going to use substitution to solve this because this one right here is already isolated for y. So it's going to be very easy to plug in 3x for y in the first equation. So I have negative 3x plus, and then I'm plugging in 3x equals negative 4. So what I get is 0 equals negative 4, and that is not true. That's false. So this is an inconsistent system. Okay, so now let's look at example 2a. We have the equation of x plus 3y equals 6 and 1/3 x plus y equals 2. So what I'm going to start doing here is trying to get, put it in slope-intercept form because I have a feeling here that these are going to be the same equation. So let's solve for y. So I subtract x from both sides. I get 3y equals negative x plus 6. Divide each term by 3, I get y equals negative 1/3 x plus 2. And sure enough, that's what this equation is going to be. So if I subtract 1/3 x from both sides, I get y equals negative 1/3 x plus 2. So these two equations that they gave us were just in different forms to begin with. And then when I put them in a form that is the same, I can see that they are the same equation. If they're the same equation, that means that every solution for x and y will work. So it has infinite solutions. Let's take a look at it if we solved it a different way though. And I use substitution here. So I have both of the equations that I did above. I'm going to put this one into slope-intercept form so that I can substitute negative 1/3 x plus 2 for y in the first equation. So that's what I'm going to do. X plus 3 times negative 1/3 x plus 2 equals 6. So I have x plus, I'm going to distribute 3 times negative 1/3 is, this is all going to cancel and be negative 1x. And then we have plus 3 times 2, which is 6. So x minus x is 0, plus 6 is 6. 6 equals 6. And so we see that it has infinitely many solutions. Okay, so let's take a look at example number 3. We have two equations, x minus 1/4 y equals 3/4, and 2x plus y equals 1. I'm going to put them both into slope-intercept form. So this is this equation in slope-intercept form, y equals 4x minus 3, and this is the second equation in slope-intercept form, y equals negative 2x plus 1. I didn't show you all the steps, but I know you know how to solve the steps, so at this point we're going to just go with these two. What I'm going to do though is I'm going to substitute negative 2x plus 1 into the first equation, the original equation. So I have x minus 1/4 times negative 2x plus 1, so I substituted there, equals 3/4. And now I go ahead and solve, so I'm going to distribute here, and then go ahead and do the math on that and keep going. I'm going to add 1/4 to both sides, so I use APO here. Okay, so then here I'm going to use DPO, and so I get x is 2/3. Okay, so now let's keep going on this. We're going to now substitute x, which is 2/3, into the second equation. So 2 times 2/3 plus y equals 1. So I have 4/3. 2 times 2 is 4, 4/3, plus y equals 1. And then I'm going to subtract 4/3 4/3. Okay, and then I got y equals -1/3. So my solution is 2/3 and -1/3 for x and y. And so now we're going to need to determine what type of special system this is. So up here we have a definition of a consistent system. A consistent system has at least one solution. Oops, that's supposed to be 1. I'm going to fix that. And then an independent system has exactly one solution. So this system of equations is consistent and independent. So one final thing on this is I put them in y or slope-intercept form so that we could graph them to make sure that they are an independent system where they have exactly one solution. So I went ahead and graphed y equals 4x minus 3. That's the yellow one. And then the red one is y equals -2x plus 1. So then we look and we see that there is just one solution, and it intersects right here before the 1 where they cross. And so that's at 2/3 and a little bit above where it's, or below where it's -1/3. It's hard to see on my tiny little graph. But you would graph it to make sure that it is an independent system, because we know it has at least one solution. And then to confirm, you can graph and find it out that it is independent. So consistent and independent is the correct label for that one. So these were special systems of linear equations. We found them to be inconsistent where there's no common solution, or there might be infinite many solutions if you get a true statement, and then you might also have it to be consistent or independent. So that's it for this lesson.